All right, good morning, everybody, and welcome to this webinar about CerTran and SuperTest, which is organized by Solid Sands and our partner BUGSENG. In this webinar, we will present a solution for continuous C and C++ compiler qualification. But first, I will start with giving you a short introduction to Solid Sands. Solid Sands is an Amsterdam-based company, and we are the one-stop shop for C and C++ compiler and library testing, and for related safety services. We have a lot of experience in compiler and library qualification for functional safety, and both Solid Sands and our customers all over the world have used our products for many qualification projects related to automotive, industrial, railway, and medical software. So with our products, you can make sure that really the toolchain that you use and the compiler that you use are suitable for use in safety-critical software projects. I would also like to briefly introduce our Italian partner, BUGSENG. BUGSENG is a leading provider of solutions and services for software verification, and it is best known for its software verification platform called ECLAIR for the automatic analysis and verification of C and C++ programs. Like I just mentioned, Solid Sands is specialized in compiler and library testing and also in qualification for functional safety. And today our main focus will be compiler qualification. So let me give you an introduction to that. Now, as most of you will know, the compiler is a crucial tool in any software project. It takes care of translating source code that you write to executable code that the hardware will understand. So yeah, without a compiler, obviously most software can never be executed. Now, when we talk about safety critical software, the term crucial tool gets an even more important meaning because I just said without a compiler, your software can never be executed. But it also means that without a compiler that is used safely, your software also can never be safe. So that is why functional safety standards such as ISO 26262 for automotive software require you to create confidence in the use of your compiler. The common way of creating that confidence is validating the compiler against the specification of the compiler. And in the case of a C and C++ compiler, that specification is the ISO C or C++ language specification. These are standardized documents that exactly specify how constructs in your code need to behave when they are being executed. Now, the goal of compiler qualification is not to prove that the compiler is free of errors, because no compiler really is. The goal is to be aware of its errors, because that way you can work around the errors and still make sure that the code that you write is not impacted by any compiler errors, and therefore it is being compiled in a safe way. Now, this process that I just described is established practice in all kinds of safety-critical software development, and that includes automotive software, railway software, robotics, and all the other industries that I mentioned before. Now, to get this confidence in your compiler, the easiest way really is using SuperTest. SuperTest is the test suite of Solid Sands for C and C++ compilers that contains thousands of handwritten tests and tens of thousands of generated tests. Most of which are written to verify conformance to the C and C++ specifications. So that way, with SuperTest, you verify that the compiler correctly implements the specification of C and C++, and that, of course, helps you to get this confidence that you need to have in your compiler when you want to use it in a safety-critical project. SuperTest verifies that correct programs are being compiled correctly, but it also verifies that incorrect programs are diagnosed with a proper error message, all to make sure that the compiler really translates C and C++ as it should. But SuperTest goes really beyond just testing conformance. Many people at Solid Sands have a background in compiler development, so we really know what can go wrong when you build a compiler. So therefore, SuperTest also contains many tests for compiler internals, like the front end, the back end, optimizations, code generation for specific targets, calling conventions, arithmetic for a specific data model, and so on. All really to make sure that the compiler is tested in and out, and you really have this confidence in it working correctly. So let's take a look at some more details about SuperTest. As you can see in this graphic on the right, SuperTest supports all versions of C and C++, and it ranges from C90 all the way to C++20. Like I mentioned before, SuperTest contains thousands of handwritten tests, but we also have many generated tests. And a good example of a generated test suite is our depth suite. A depth suite provides tests for arithmetic that exactly match the data model that you are targeting. So yeah, as you can imagine, tests for 32-bit integer arithmetic are very different than tests for 64-bit integer arithmetic. And the same, of course, goes for all other data types. So with our depth suites, we make sure that there's an appropriate test suite for your exact data model. Another example of a test generator is our calling convention tester, and that verifies the correct handling of function arguments, return values from functions, and also stability of the ABI. Another example is our template-based generated Tempest, and that allows us to create several test variants based on one single template, and that way we can verify constructs in different scenarios. Also good to know is that our test driver is very easy to script, so it can be used with any C or C++ compiler and on any execution environment. And it is also very easy to create your own subset of tests. So for example, it is very easy to select all the tests for a specific version of C and C++ that you might be using. Or yeah, if you have a target that does not support floating point, yeah, it's very easy to exclude all tests that are applicable to floating point from a test run. So that way you really only test what is relevant to you. After running the test, you will get comprehensive reports in text, CSV, HTML, or XML. And of course, that you can use both for analyzing the test results, but also as evidence of what you have been testing. One of those reports is the traceability overview. And this report provides the evidence of what exactly you have tested, according to which specification, and that is what is required by functional safety standards. So on this slide, we illustrated using the V model, which is commonly used in functional safety. And as you can see, SuperTest is not on the bottom level of unit testing one specific compiler implementation, but instead SuperTest is on the level of the specification of the compiler. Now that means that as long as it is a C or C++ compiler, SuperTest will be able to qualify it. More importantly, each test in SuperTest can be traced back to the specification of C and C++. So that way it is very clear what is being tested, why it is being tested, and also this shows evidence that your testing is complete because you cover the entire specification. And it makes it possible to identify possible gaps in your test coverage. So for example, if you have forgotten to execute specific test cases, then this report will make that very clear. And that way you really make sure that your testing is complete. So yeah, to summarize, instead of blindly running just a large collection of tests, with SuperTest, you really get an overview of exactly which parts of C and C++ you are testing, by which tests it is being tested, and also, of course, what are the test results. And only by providing such an overview, you qualify a compiler in compliance with the functional safety standard. So yeah, when we look at SuperTest, qualifying a compiler for functional safety is really as straightforward as installing SuperTest, configuring the test driver, running the tests, and documenting the results. But one specific detail we have not looked at yet is the actual configuration of SuperTest. So of course, SuperTest needs to know which compiler should be qualified, but even more importantly, it also should know the use case of the compiler. And the use case of the compiler, quite literally, is the way you are using it. So yeah, as you might know, compilers have many different configuration options, such as the language version setting or the hardware you are targeting. You can turn on and off specific features or optimization. All these options change the way the compiler behaves. Now, typically, we illustrate that using a pinball machine, as you can see over here. So your code goes in here into the front end. It then goes through all kinds of stages within the compiler. And at the end, the executable code comes out. Now, as soon as you change one of the configuration options of the compiler, this path that your code takes through the compiler might be completely changed. And that means that, again, the generated code will look very differently. And a nice way to illustrate that is, for example, with optimization. Optimization is, of course, used to make code run faster, and loops are a good example of optimizable code. So in this graphic over here, you see a simple representation of a loop in your code, where we check the condition, jump to the loop body, we jump back to the condition, continue the loop until the condition is satisfied, and then we make a jump until what comes after the loop. Now, when compiling this code without optimizations enabled, the structure of the executable code is exactly the same. So the executable code is basically a representation, a direct representation of your source code. But when we change the optimization level to highly optimize the code, the resulting code might look very different. The compiler may rewrite your code to make it run more efficiently, and that way the code looks very different, but the observable behavior remains the same. And as a result, the structure of the code may become way more complicated, as you can see over here. So now we have many new branches, we have new jumps. It really changed the way the code looks, but it should not change the way the code behaves. So that is why when you change the use case of your compiler, you really need to qualify it again for that use case to make sure that this change does not insert new errors into the behavior of the compiler. Now, for this specific example of changing the optimization level in SuperTest, we have the loop optimization test suite that makes sure that the optimizations that are applied by your compiler are correct. And in a minute, you will see the importance of such a test suite, because Roberto will demonstrate that indeed changing the optimization level may not only impact the performance of the code, but it may also change the behavior of the code, which is of course not what you want. So we just looked at an example of changing the compiler's behavior when changing the use case of the compiler. But the meaning of the source code here did not change, but the way the compiler translated it did change. Now let's take a look at an example of changing the use case in such a way that the meaning of your source code actually changes. So over here we have a very simple example of a piece of code that declares a variable with the register specifier. And basically this hints to the compiler that the object may be placed in the register of the processor. Now when we compile this code with GCC and we set the use case, so the options to the compiler to compile for C++14, this code will compile without any issues. But when we change the use case to C++17, the code suddenly fails to compile. So as you can see here, the use case, the way we call the compiler, is now including the option C++17. Now, when we look at the output of the compiler's error message, it actually turns out that this register specifier is removed from C++17. So in this case, changing the use case of the compiler actually changed the meaning of your code from correct code to incorrect code. So that is why when you qualify a compiler, it is also very important to know against which version of C or C++ you are qualifying it. A C++14 compiler should obviously be qualified following the C++14 specification, and a C++17 compiler should be qualified following the C++17 specification. So also when configuring SuperTest, you really need to make sure that the appropriate test cases are selected for your version of C or C++. Now we have looked at the importance of the compiler's use case. The actual step-by-step way of qualifying a compiler looks like this. So after installing SuperTest, we really need to identify all the relevant use cases of the compiler that are used to build your software. And based on those use cases, we then need to create corresponding SuperTest configurations. For a project that only has one or two compiler use cases, this is very straightforward. But as this number increases, you really need to dig through complicated makefiles, build scripts, and so on to identify all these different use cases. For example, Roberto recently found that the open source Xen hypervisor uses 40 different use cases to build the software. And as part of those 40 use cases, 3 different versions of C are being used. Now, obviously, manually identifying all these different use cases and then creating SuperTest configurations becomes very error prone if you need to do this 40 times. Now, luckily, Roberto will now take over from me, and he will demonstrate a much easier solution to qualify so many different compiler use cases.
Okay, so manually obtaining the use cases, as Remy said, is error prone, and also this if you do this part of the configuration manually, then this doesn't fit well with important industry trends that I will examine in a second. So first of all, systems today are composed by an increasing number of components that often come from different sources, and they have their own build procedure, and they typically use the compilers in different ways. So when you are building a complete project, you may take, I don't know, a real-time operating system, maybe an open source one, or a proprietary one. And of course, it's extremely unadvisable that you go and tweak the build procedure of the operating system you are using. So typically, the compiler option have been chosen in a very specific way, and it is something that you would better leave alone. Here's another example. Consider modern systems that have, I don't know, maybe a machine learning component, and those components will have compiler options to tweak the floating point arithmetic optimization so as to find the right trade-off between accuracy and performance, and there may be other components that have to face completely different trade-offs. Another trend that has to be taken into account when we talk about compiler qualification is shifting left. Shift left is not a new idea. It's an idea that dates back to more than 20 years ago. And the idea is to anticipate as much as possible the test activities. Here we see the classical V diagram where the left-hand pointing arrows exemplify what is meant by shifting left. So shifting left the testing activities as much as possible in order to be able to spot problems or opportunities for improvement as early as possible. And the qualification of translation toolchains, meaning the compiler, the linker, the assembler, the librarian, and these also ought to be shifted left as well for many kinds of modern projects and which are developed across a time that may be measured in years or even decades. Another trend is continuous integration. Continuous integration plays, of course, very well with the shift left idea, because continuous integration has to do with full automation and repeatability and reproducibility, and not only is in line with the shift left movement, but it's also very much in line with the spirit of all functional safety standards, because doing things in a continuous integration setting forces you to make a great investment into full automation and repeatability and reproducibility of the results. And the connection with compiler qualification is that if there is a problem in your compiler use case, you want to know earlier rather than later. And if you have, especially if you have to tweak your compiler use cases, because, for example, you need some extra performance, or because thanks to compiler qualification, you have discovered that you are affected by a small bug in the compiler, you will have to work around this problem. So, and doing this in continuous integration and qualifying the compiler continuously as it is possible with CerTran is clearly a great advantage. So what is CerTran? It's a joint solution by BUGSENG and SolidSense. For the BUGSENG part, it is based on the ECLAIR Software Verification Platform, and especially on one of its features that is there since ever. meaning that ECLAIR works by intercepting all the invocations of the translation toolchain components, the compiler, the assembler, the linker, the librarian, and this independently from the build procedure. So whether it is makefile based or script based or ninja based or any combination, doesn't really matter. Okay, analysis with the ECLAIR Software Verification Platform will intercept at a very low level in the operating system all the invocations of the translation toolchain components. It will obtain from the operating system all the options that are passed to the compiler, and also ECLAIR contains a very precise model of each compiler, and also assembler, librarian, and so on, and meaning that it has a complete understanding of the semantics of each option and how these options influence the behavior of the tool. Also, it has a complete understanding of what it means not passing an option to a certain tool, meaning that it contains an encoding of the defaults that every toolchain component has. So this means that ECLAIR obtains all the information that is required to recognize the use cases of the compilers. And so all the use cases are automatically detected, and CerTran automatically produces the required SuperTest configuration for each of the detected use case. And as Remy said, the use cases may be a significant number, so it's also a way, CerTran, in which you can not only save a lot of time, but also defend yourself from the possibility of committing mistakes in compiling the configuration by hand. And CerTran optionally executes the SuperTest automation machinery in order to qualify the compiler for all the detected use cases. And all this possibly within a continuous integration system. So I will give you now a small demonstration. Here is an installation of CerTran under GitLab. ECLAIR has very good support for Jenkins, GitLab, GitHub. It basically can be integrated in any continuous integration system. And here we can see a demonstration project, and I will demonstrate the basic idea, telling you a little story. So at some stage, the designers decided to set optimization level to 2. And here we see what they did. Well, they simply added -02 to the options that will eventually be passed to the compiler, which is GCC. And something happened. So CerTran, immediately after this commit was pushed, did the compiler qualification, and something happened. So there was a new failure of one of the compile time tests of SuperTest, but 2 failures for the runtime tests that were already present, they remain the same. So as Remy said, there is no compiler that is free of bugs. All have bugs, and GCC is not an exception. In particular, this version of GCC. So let me show you what happens. So this is the output by SuperTest. So the runtime test, there were 2 tests failing previously, and they keep failing. And also there were other 2 tests that caused compilation error. So one having to do with macros and complex numbers, and they were failing, and they are now failing again. So nothing changed. What changed is this stress testing for the compiler, which is basically a monster C program. Compilation succeeded previously, but it failed now. So This, from the point of view of safety, the addition of -0.02 did not cause anything new. The fact that the stress test fails means nothing. Simply, really, T-stress1 is a monster C program that GCC can compile without optimization, but cannot compile with optimization. Okay, so this was the first commit I wanted to show you. Well, then the engineers decided that with -0.02, their system was not quick enough. So they said, oh, maybe we have to switch to optimization level 3. And here is the path. They changed it, -0.02 into -0.03. But now something really bad happened. And in particular, we have 32 new runtime failure, same number of compiled time failure. That compiled time failures are not an issue for safety. So if a program doesn't compile, this is not a safety issue. It's a safety issue when it does compile, but it compiles to something that is wrong. So here we have a significant number of new failures. So this is the regression. So we have 32 tests in SuperTest that were previously passing, and now they are failing. So this is not good. So let's say in our story, let's say that the people running this project, they got in touch with the solid sense expert, and they said, these tests that are failing, they are very likely connected to this loop vectorization. And so this is why we have this commit. So we keep -0.03, but we disable 3-loop vectorization. And you see that the thing that happens is good. So the 32 failures that were added in the previous commit are now fixed. So if we look at it, okay, so they were failing before, and now these tests are passing. So we are, with this combination of option, -0.03 -f, no 3-loop vectorized, we have exactly the same result we had with -0.02, which is good. Okay, back to Remy now.
Thank you, Roberto, for the very nice live demonstration. So yeah, I think from this demonstration, it is very clear that CerTran and SuperTest together really brings compiler qualification to the next level. Compiler qualification can be fully automated. It prevents errors of doing configuration manually, but it also allows you to find compiler errors as early as possible in your development process. CerTran will be part of version 3.13.0 of the ECLAIR Software Platform, and that will be certified following a wide range of functional safety standards as well. So that way it is really set to get going with the compiler qualification in your functional safety related project. Thank you all for attending this webinar, and let's now proceed to the Q&A session. So let me see if any questions have come in. Yeah, I see one question that I think I should pick up, which is asking, when we talk about the compiler toolchain, this needs to be validated against the specification of functions used in a safety critical project. And because there are more functions than only compilation of a version of a particular C or C++, why do you consider then the compiler qualified if SuperTest validates it only against a particular version of C or C++? Well, I think actually, yeah, of course, it's good that you know that we've validated it against the specification of C and C++. And that is, of course, the main requirements that the compiler need to comply to when you compile C or C++. But actually, yeah, like I mentioned in my slide as well, we do not only validate compliance to the C and C++ specification, we really are aware of compiler internals and what can go wrong there as well. And I think a good example was actually the live demonstration of Roberto, where he showed adding optimization option, and then we find that optimization breaks your code. Well, actually, the C and C++ specifications, they don't say anything about optimization. They say optimization is allowed as long as the observable behavior of the program remains the same, and that's about it. So yeah, from there, we actually don't validate anything in terms of optimization because there is no specification of it. We validate optimization based on our knowledge of how a compiler works, what kind of optimizations may be applied. And for that, we then have a dedicated test suite to verify also that functionality of the compiler. And of course, we have many examples of other cases like depth suites for arithmetic testing or calling conventions and ABI stability. So, of course, an important part of compiler qualification is verifying it against the specification of C and C++. But yeah, with SuperTest, you really do a lot more. And I think that is definitely a good thing because you should make sure that also that functionality of the compiler is working as it should. Roberto, do you see any questions that you might pick up?
Yeah, so I would like to provide a little bit more about this question. So one thing that is important to understand is that with SuperTest, you are actually testing the entire toolchain. So not just the compiler. SuperTest exercises, of course, also the assembler and the linker, because in the end, the way SuperTest works is by executing the program. So you are really testing the entire translation toolchain from the preprocessor and down to the final executable. So this has to be compared with other approaches. I guess some of you have heard about CompCert. CompCert is a certified compiler, but it's only certified. So the preprocessor is not certified. It's only the compilation step that is certified. The assembly is not certified, and the linker is not certified. In contrast with SuperTest, you do a end-to-end verification. It is true that in some cases, so many projects, especially embedded projects, they use complicated linker scripts that are very specific, very specific to the project. So of course, SuperTest doesn't. So you cannot in generally test such very specific linker script because linking will fail if you are not linking together a prescribed set of object modules which have maybe specific section names and so on. I hope I have contributed to clarifying this question.
Thank you very much, Roberto. Yeah, I think related to this linker script, what is nice to add here is that, of course, you can integrate those into the SuperTest configuration. So in the end, SuperTest is just a very large test suite of many C and C++ programs. And if you use this linker script to create the executable for your target as part of the testing, then at least you verify that, yeah, the linker script integrated with all these different C and C++ programs is working as it should. So with that, you really have, like Roberto just mentioned, the entire step-by-step process of compiling and linking a C++ or C program. You have verified that. I see one
Great.
other question, I think, for you, Roberto.
Yeah, so there is a question, what about compilers that take options not just from the command line? Yes, so of course these are handled because there are really many compilers that are able to take compilation options in addition to the command line via environment variables. And some also have scripts, configuration scripts. Some of them are in at fixed places. Others can be controlled by the user. And yeah, of course, ECLAIR for each of the supported compilers, which include basically all the compilers that are in wide use today in the industry, is able to capture the exact options that have been provided independently from the mechanism with which they have been provided.
Thank you, Roberto. I think those were all the questions that came in. So, oh, I just see another question coming in, actually saying which compilers are supported by CerTran. Yeah, from the perspective of SuperTest, all the C and C++ compilers are supported, because SuperTest can be very easily configured to use any kind of C or C++ compiler. Roberto, do you have any addition to that?
Basically, all the compilers that are in wide use today are supported. I can provide a list of family if you give me just a second. Okay, so all in the Clang family, or the Cosmic compiler, the Crossword compiler, all the ones based on GCC, Green Hills, all the Keil compilers, both the legacy version and the newly branded ARM compilers, all the IAR compiler, Intel, Microchip, MLab C and MLab X compiler, Microsoft Visual Studio, and QCC, Renesas, various families of Renesas compilers, the Softtune compilers, Tasking, Texas Instrument compiler, and Wind River. So it's basically all that. Yes, CerTran needs to know the vendor-specific options. Exactly. So one of the things in which the development of ECLAIR had to be very, say, ad hoc was in the way it uses to parse and capture the options given by the different compilers. So some of them have languages of options that are a nightmare. For example, the Wind River Diab compiler, it has a specific manual of synonyms for options. So the same options as literally dozens of variations which have a different syntax. But yes, all this is supported, and it has been supported before. So CerTran is not really based on new technology as far as ECLAIR is concerned. It's a use of an existing technology. So recognizing the ways in which the compiler is used was anyway absolutely necessary, because in C and C++, there are hundreds of implementation-defined behavior. And in order to perform static analysis, you need to know what are the implementation-defined behaviors that are implemented by the compiler, the way you are using the compiler, meaning taking into account all the options.
Thank you, Roberto. I think, that brings us to the end of the webinar. So I would like to, of course, thank you, Roberto, for the nice presentation, and also everyone attending for the nice questions as well. And have a very nice day.
Thank you, Remy. Thanks, everybody. Bye-bye.